Now we shall discuss about the different type of solids. So first we shall discuss about a cube. So I hope you all know about what are the specialities of a cube. For a cube we will be having six faces. Each of them will be squares. Okay, so here we are having one face, on the other side we are having another face, and along these sides we are having four more faces. So 2 plus 4, we are having 6 faces. So if the solid is resting on the horizontal plane, and if you are observing from the top, we can see the top view as a square. With its true dimension. So this face it is known as an end face, and the face on which it is resting, okay, on the bottom side we have got a face, so this face on which it is resting, the cube is resting on the horizontal plane, it is known as the base. Okay, base is also an end face, this is also an end face. So when the solid is resting in this position on the horizontal plane, and if you are watching from the top, you can see the top view as a square, and along the four sides we have got four square faces also. Here we are having a square face, here we are having a square face, here and here also we are having square faces. Okay, and we have got 8 corners for this cube. So here this is one corner, this is another corner, this one, and likewise on the base also we are having 4 corners, 1, 2, 3 and 4. So likewise 4 plus 4, you are having 8 corners. So now it is resting on the horizontal plane on its base, which is an end face. Okay, so the edges which are along the base, this is a base edge, this is known as a base edge, this is also a base edge, this one is a base edge, and this is also a base edge. This is known as a base corner. Here also we have got a base corner, here also and here also. So when it is resting on the horizontal plane, you have got 4 base edges, 4 corners of the base, and it has got how many edges? It has got 4 plus 4 plus 4, 12 edges. Okay, it has got 4 base edges, 1, 2, 3, 4 base edges, and on the top face you have got again 1, 2, 3, 4 edges, and along the sides also, here we are having an edge, here also we are having another edge, here we are having another edge, and on this side also we are having another edge. So 4 plus 4 plus 4, totally you are having 12 edges. So it has got 4 plus 4, 8 corners, 4 plus 4 plus 4, 12 edges, and 6 square faces. So these are the specialities regarding to a cube. And when you are observing from the front, if you are observing in this particular direction, the front view also will be a square. And you will be able to see the dimensions in the correct way when you are observing from the front. And again, one more thing you have to notice, when you are observing from the top, this is a corner, this is another corner, this is a corner, and this is another corner. So below this corner, along this side, actually we are having an edge, but we are not able to see that edge. And just below this corner we have got one more corner also, and presently you are not able to see that corner also. So when you are observing from the top, you will be able to see this corner, but you won't be able to see this edge and the other corner. In the same way, this corner is visible, but this edge is not visible, and the other corner, it is also not visible. Likewise, it is applicable to this corner and this corner also. Here also we have got an edge, but it is not visible in the top view. Here also we have got an edge, but it is also not visible in the top view. The corner which is on the other side, which is on the base, is also not visible. Here also the base corner, it is not visible, is it? So again, when you are considering the edges, so here we are having an edge. So just below this edge, along this side, we have got a square face that is also not visible in the top view. Here also we have got an edge. So just below this edge, we have got another square face, but it is also not visible. So like this edge, we have got one more edge on the base. That edge is also not visible in the top view. And when you are observing this edge and this edge, these two edges are visible, but the square faces and the base edge which is on the other side, it is not also visible. And here also this edge is visible, but this square face and this base edge which is on the base, it is also not visible. So these are the specialities when you are observing it from the top. So this is a cube. All the edges are having the same dimension. All the faces are having equal dimension. That is why it is known as a cube. So when you are observing from the top view in this particular position, when you are observing from the top view is a square, the front view is a square, and the side view also will be a square. Now we shall consider the front view of the cube. So when you are observing from the front, you will be getting the projections on the vertical plane, is it? So when you are observing from the front, so in this case, you can see the front view of the cube as a square, and you are not able to see the other faces, is it? In the front view, you will be able to see 4 edges, 1, 2, 3 and 4 edges, 4 corners, 1, 2, 3 and 4 corners. So in the front view, 4 edges and 4 corners are visible, and the other faces and other corners, edges, everything, it is invisible in the front view, is it? So if you consider this edge, so behind this edge actually we are having a square face, and here we are having another edge also. Behind this corner actually we are having an edge, here we are having an edge, and behind that again we are having a corner. So all those things are not visible in the front view. If you consider this side, here also this edge is visible, but the face that is behind this edge, it is not completely visible, is it? So the front view of this cube is it is again a square. The front view of the cube, when you are observing from the front, it is again a square. Okay, and you can see the square in its actual dimension. Now we shall discuss about a square prism. So this square prism is also having 6 faces. So here this is a square prism, this one is a square prism. So what are the specialities which are related to a square prism? Now this is an end face of the square prism, and this is another end face of the same square prism. Now I am keeping the square prism on the horizontal plane, and so this is an end face and this is also an end face. This face is known as the top and this one is known as the base. Okay, this is the base. So it is resting on its base. This is the top face. And here also you have got, as I have mentioned, we have got 6 faces, out of which 2 of them are squares. Here we are having a square face. On the other side also we have got a square face. And along the sides we have got 1, 2, 3 and 4 rectangular faces. We have got 4 rectangular faces. So we have got 2 square face, one on the top, another one on the bottom, and 4 rectangular faces along the sides. So this is an end face, the other one is also an end face, and each of the rectangular faces, they are known as lateral faces. Okay, so here we are having an edge. So likewise here also we have along the base we have got 4 edges. These are known as base edges, 1, 2, 3 and 4, and it has got 4 corners on the base, 1, 2, 3, 4. So likewise along the top face also it has got 4 edges, 1, 2, 3 and 4. Here also 4 corners, 1, 2, 3 and 4. So it has got 4 plus 4, 8 corners, totally 6 faces, out of which 2 are squares and 4 are rectangles. So in this particular position, all the faces which are on the side, they are known as lateral faces. And it has got how many edges? As in the case of a cube, this is also having 4 plus 4 plus 4, 12 edges. So when you are observing from the top, you can see 1, 2, 3, 4. 4 edges are visible. The edges which are on the base, this is the base, 1, 2, 3, 4. So these four edges which are along the base, they are not visible in the top view. They are not visible in the top view, and four corners on the top end face are visible, but the four corners on the bottom face or the base, B-A-S-E, base, they are not visible in the top view. And here, just below this edge, we are having a square, we are having a rectangular face. Here also we are having a rectangular face. Here also we are having a rectangular face. Here also we are having a rectangular face. But all these rectangular faces, they are not visible in the top view. Okay, so this edge, actually when you are observing it from the top, this is actually representing a rectangular face also. This corner is actually representing this edge also. Here we are having a lateral edge, so this is known as a lateral edge. This is also another lateral edge, and likewise we have got here also we have got a lateral edge, and here also we have got another lateral edge. Okay, so when you are observing from the top, we can see the top view only as a square, but you are not able to see this rectangular face, this rectangular face, this rectangular face, and this rectangular face. They are not visible in the top view. They are not visible in the top view. So we can say like this: this edge, when you're observing from the top, actually it is representing a rectangular face and the base edge also, which is invisible in the top view. This edge, which is visible in the top view, it is also representing a rectangular face here and a base edge also. This corner, which is visible in the top view, it is also representing a lateral edge and a base corner. So likewise it is applicable for this edge, this corner, this edge, this corner also it is applicable. Only in the top view it is completely visible as a square. So what about the front view? When you are observing from the front in this particular direction, the front view is a rectangle. The front view is a rectangle. So this is the rectangular face. When you are observing from the front, you can see it as a rectangle. Okay. Now we shall consider the front view of the square prism. So when you are observing from the front view of this particular square prism, it seems to be a rectangle. So you can see four edges, is it? You can see 1, 2, 3 and 4 edges, and in the same way you can see four corners also, 1, 2, 3 and 4, is it? So if you consider this square prism, behind this edge we have got a rectangular face. This is invisible in the front view. Behind this edge also we have got a square face, that is also invisible in the front view. Behind this edge we have got a square face, that is invisible, and behind this edge again we are having a rectangular face, that is also invisible, is it? So behind this edge again we have got one more edge along this side, that is also invisible here, and behind this one and this one also we have got edges, but in the front view it is invisible. In the same way, behind these four corners, 1, 2, 3 and 4, we have got four more corners, 1, 2, 3 and 4, and all of them, they are invisible in the front view, is it? So the front view of this particular square prism, this is a rectangle, and you can see the true dimensions of the rectangle in the front view. You can see the true dimensions of the rectangle in the front view. So this is about the front view of the square prism. Now we shall discuss regarding a hexagonal prism. So as you can see the end faces. So here we can see a hexagon. Here also we are having another hexagon. I am placing the object on the horizontal plane. And when you are observing from the top, you can see a hexagon. You can see a regular hexagon. So what do you mean by a regular hexagon? All the edges, they are having equal length. Okay, and what is the axis of this particular prism? So axis is a line that is actually joining the center of this hexagonal face to the center of this hexagonal face. You consider an imaginary line that is joining the center of this hexagonal face to the center of this hexagonal face. You can call that imaginary line as an axis. So this is an end face and this is also another end face. When this is resting, when this solid is resting on this end face on the horizontal plane, that particular end face is known as the base, and this is the top face. Top face is also a regular hexagon. So in this case you have got two end faces which are hexagons, and you have got 1, 2, 3, 4, 5, 6. You have got 6 rectangular faces. You have got 6 rectangular faces for this particular hexagonal prism. So if the height is reduced to some extent, sometimes this faces may be also squares, but usually it is rectangles. So when you are observing from the top, you can see 1, 2, 3, 4, 5, 6 edges and 6 corners also. 1, 2, 3, 4, 5, 6 corners is also visible in the top view, but you are not able to see this rectangular face, this rectangular face, this one, and this one also. They are not visible in the top view. So you can say like this edge is actually representing this rectangular face also in the top view. Likewise, this edge is also representing a rectangular face in the top view. Okay, so here it has got how many edges? Here you are having 1, 2, 3, 4, 5, 6. So on the base 1, 2, 3, 4, 5, 6. So 6 plus 6, it is 12 now. Then these edges 1, 2, 3, 4, 5 and 6. These are known as the lateral edges. Okay, so 6 plus 6 plus 6. Total it has got 18 edges. 6 plus 6, 12 corners, and 2 plus 6, that is 8 faces. Okay, out of which 2 are regular hexagon and the other one it is square rectangular faces. Okay, so that is about a hexagonal prism. So in the top view you can see it as a regular hexagon, but when you are observing from the front in this particular direction, the front view, the outline of the front view will be a rectangle. Now we shall consider the front view of the hexagonal prism. So this is a hexagonal prism. Already we have seen the top view of the hexagonal prism. Now we shall consider the front view of the hexagonal prism. So when you are observing from the front, you can see the front view as a rectangle, is it? The outline of the front view is a rectangle. And you can see 3 lateral faces of this hexagonal prism. Here we are having a lateral face, here we are having another lateral face, and onto this side also we have got another lateral face. So 3 of the lateral faces which are rectangles, they are also visible. Altogether the outline of the front view is a rectangle, is it? Here we are having the base. The base is a hexagon, a regular hexagon, that is not visible in the front view. Here we are having the top face, and this top face is also a regular hexagon. This is also not visible in the front view, is it? So altogether when we consider the front view of the hexagonal prism, the outline of the hexagonal prism is a rectangle. The outline, what do you mean by the outline? Outline means when you are observing from the front, we can see an edge here, is it? You can see an edge here, again one more edge here, another edge to the base, and another edge to this side. So altogether this constitutes a rectangle, is it? So the front view of this prism, this regular hexagonal prism, is a rectangle, is it? Now we shall see about a pyramid. Okay, we shall see about a pyramid. So in all the previous diagram we have seen in all the previous cases we have seen prism. So what is the speciality with a prism? In case of a prism, the end faces will be the same, is it? The end faces, this will be an end face and this is an end face. Both of them will be having the same shape, is it? So if it is a regular hexagon, here we are having a hexagon, and here also we are having a hexagon. This is a hexagonal prism. So in this case we have got a pyramid. So this is a pyramid. So what is the speciality with a pyramid? It don't have identical end faces. It will be having a face here, but just opposite to that face we won't have another face. Instead of that we will be having an apex or vertex. Instead of that we will be having an apex or vertex. So in this case, this is actually a square pyramid. It is actually a square pyramid. So why it is called as a square pyramid? It is called as a square pyramid because of its base shape. Okay, so here the base shape is a square. Here the base shape is a square. Now it is resting on the base on the horizontal plane. So when you're observing from the top, the outline of the top view. So this is the outline of the top view. Here one line, here another line, this one and this one. So combining all these four lines, totally when you're observing from the top, you can view it as a square. You can view it as a square. So four base edges, they are visible in the top view. 1, 2, 3 and 4. Four base edges, they are visible in the top view. And what about the other faces? So here we are having a triangle. Here we are having an isosceles triangle, is it? So here this is a triangle, this one is a triangle, this one and this one is also triangle. So it has got four triangular faces. All of them are identical in their dimension, and all of them, for the time being, for this case, it is an isosceles triangle, is it? So here this face is also known as a slanting face. Okay, this face, it is also known as a slanting face. This is a slanting face. This one and this one also are slanting faces. This particular point, you can call it as apex or vertex, and this one is known as a slant edge. This is another slanting edge, this is another slanting edge, and this one is also another slanting edge. It has got four slanting edges, four base edges. This is a slanting face. It has got four slanting faces also. So totally a square pyramid, it is having 4 plus 1, 5 faces, out of which four faces are triangles and one is a square. So when you're observing this square pyramid from the top view, how many edges can you see? When you're observing it from the top view, you can see 4 slanting edges and 4 base edges. Okay, so the outline of the top view of this square pyramid is actually a square. So 1, 2, 3, 4. It has got 4 base edges. So the outline, the boundary of the top view is actually a square. Along with that square, from the center of the square, you can see slanting edges also. Okay, so the top view of a square pyramid means it is containing the outline as a square, and inside the square you have got 4 slanting edges also. Okay, it has got 4 slanting edges and 4 base edges. It has got 4 corners along the base, 1, 2, 3 and 4, and here we have got an apex. So this is the speciality regarding a square pyramid. So what do you mean by the axis of the square pyramid? You consider a line, an imaginary line that is connecting the apex or vertex and the center of the base. Okay, joining perpendicularly to the base. So you consider an imaginary line starting from this end point to this base. You imagine that this line, which is an imaginary line, it is perpendicular to the base. So that type of a line, it is known as the axis of the corresponding pyramid. Okay, axis. Okay, so height of the pyramid means height of the axis. It will be the height of the axis. So when it comes to a hexagonal prism, the height of the axis means the height of the prism itself. The same is applicable to a square prism also. The height of the axis means the height of the corresponding prism. Now we shall consider the front view of a square pyramid. So we have already seen the top view of the pyramid, square pyramid. Now we shall consider the front view. So when you are observing from the front view of the square pyramid, it seems to be a triangle. It seems to be an isosceles triangle, is it? So when you're observing from the front, you are not able to see the base, is it? You are not able to see the base, which is a square, and you are not able to see the other slanting faces, which are triangles, is it? You can see an edge here, you can see another edge on this side, and you can see one more edge on this side, is it? So 3 edges are visible. This apex is visible, this corner is visible, and this corner is also visible, is it? So along the base we can see only one edge, and along this side we have got an edge, but this is not visible in the front view, is it? So just behind this corner we have got one more corner, but actually it is not visible in the front view. And behind this corner also we have got one more corner. That corner it is also not visible in the front view, is it? And this edge also it is not completely visible in the front view. The front view of a square pyramid, when it is resting in this position, it is a triangle. Now consider another solid. So this is known as a cylinder. This is known as a cylinder. Okay. So now it is resting on the horizontal plane. So when you're observing from the top, you can see the top view as a circle. You can see the top view as a circle. So this is a cylinder which is having two end faces, is it? The end faces of a cylinder will be two circles. So here we are having a circular face, here also we are having a circular face. The end faces of a cylinder, they are circular. Okay, and here we are having a curved surface. Here we are having a curved surface, is it? Here this surface is completely curved, and these two end faces are circular in their nature. So when you are observing from the top, you can see the top view as a circle. Okay, and here this is the base. Presently it is resting on the base, and that base is also circular. So this is top face, another one is the base, and it has got a circular surface also. It has got a circular surface it has got a circular surface also, and along this circle we have got infinite number of points. Along the circle we have got infinite number of points. You may consider each of these points as an edge. You may consider each of these points as a corner. Okay, so here this is the base circle. So along the base circle we have got infinite number of points, and each of these points along the base we can consider it as a corner. So the same is applicable to the top side also. You have got a circle here. Each of the points along the circle you may consider it as a corner also. But if you consider this circular face, so what about the circular face? You consider a straight line that is joining from the top circle to the bottom circle. Okay, from a point on the top circle to a point on the bottom circle, imagine that you are drawing a line. Okay, so that line it is known as a generator. That line you can call it as a generator. You can call it as a generator. So likewise you have got infinite number of generators along the surface, along the curved surface of the cylinder. Okay, each of those generators can be considered as a lateral edge. They can be considered as a lateral edge. Suppose this solid is resting on the horizontal plane on the circular face, you can say that it is actually resting on a generator. You can say that actually it is resting on a generator. Okay, so it will be resting on a single line along the circular surface. So I am keeping the solid on the horizontal plane. So consider the front view. So here when you are observing in this direction, the front view will be a rectangle. Is it? In this case it will be a rectangle. Okay, presently I am focusing the camera from the top. So the top is a circle, and when you are observing from the front in this particular direction, it can be viewed as a rectangle. You consider a line that is connecting the center of the top circular face to the bottom of the circular face. You consider an imaginary line, and that imaginary line is known as the axis of this cylinder. The axis of this cylinder. Okay, a line connecting the center of the top face to the center of the bottom face, it is known as the axis. Now we shall consider the front view of a cylinder. Okay, so this is a cylinder. Already we have seen the top view of the cylinder. Now we shall consider the front view of the cylinder. So when you are observing from the front view of the cylinder seems to be a rectangle. Is it? It seems to be something that is similar to a rectangle. So the outline of the front view, it is a rectangle. Is it? You can see an edge here, something like an edge is visible here. Here also you can see an edge. Here also you can see another edge. So the front view of the cylinder, it is a rectangle. Okay, if the diameter of the circle and the height of the cylinder, they are equal, it also can be a square. Is it? If the diameter of the base circle and if the height of the cylinder, if they are equal, it can be also treated as a square. Now this is the next solid. So this solid, it is a cone. This one is a cone. This one is a cone. So what is the speciality regarding a cone? So the cone will be having the base as a circle. Okay, here we are having the base, which is a circle. It is kept on the horizontal plane. It is kept on the horizontal plane. Now it is resting on the base. This point is known as apex or vertex, and it has got a curved surface. It has got a curved surface also. Okay, so this is about a cone. You consider an imaginary line that is joining the apex to the center of the base. Okay, to the center of the base, you consider an imaginary line joining from the apex to the center of the base. So thus that line is known as the axis of the corresponding cone. So in this, in the case of a cone also, here we are having a circle. Each of the points along the circle, you may treat it as a corner also. You may treat it as a corner, and you consider a line that is connecting the the apex or vertex to any point on the corresponding base circle. So connecting the vertex and the base, you imagine a line. So likewise, you can draw infinite number of lines from the apex to any point on the base circle. Each of those lines, they are known as generators. Okay, they are known as generators. Okay, so you may consider infinite number of lines that are joining the apex and any point along the base circle. So likewise, we can draw infinite number of lines, and each of those lines, they are known as generators. Okay, so when the solid is resting like this on the horizontal plane, we can say that actually it is resting on one of its generators. Okay, so this is about a cone. So regarding the cone, the top view will be a circle, and when you're observing from the front view will be a triangle. Is it? When you're observing from the front view will be a triangle. Okay. Now we shall consider the front view of this cone. Okay, for the front view of this cone. So in the front view of this cone, this is a triangle. Is it? This is a triangle. You are not able to see the circular surface completely, and you are not able to see the base also completely. The front view of this cone, the front view of the cone is a triangle. You can consider this solid. So what type of a solid is this? This one is known as a sphere. Okay, this one is known as a sphere. It is having a circular nature. Okay, it is having a circular nature. So when it is resting on the horizontal plane, the top view is a circle. What about the front view? The front view is also a circle. Is it? Both the top view and the front view, they are circle. And the dimension of a sphere, you can call it as spherical radius. So now we shall consider the front view of the sphere. The front view of the sphere, it is a circle. The top view of the sphere is a circle, and the front view of the sphere is also a circle. Okay.